Good afternoon. Today, we will discuss the Chapter 12, Geology and Non-renewable Mineral Resources. The crucial importance of rare earth metals. Mineral resources extracted from the Earth's crust are processed into an amazing variety of products that can make our lives easier and provide us with economic benefits and jobs. Mineral resources such as gold, copper, aluminum, sand, and gravel. But people are generally much less aware of the rare earth metals and oxides, some of which are crucial to the major technologies that support today's lifestyles and economies. Rare earths are used to make liquid crystal display, flat screen for computers and television sets, energy efficient, compact fluorescent and LED light bulbs, solar cells, fibers, optic cables, cell phones, and digital cameras. As you can see, they are also important in the manufacture of batteries and motors for electric and hybrid electric cars, catalytic converters in car exhaust systems, jet engines, the powerful magnets in the wind turbine, generators, and solar cells. Rare earths also go into missile guidance systems, smart bombs, aircraft, electronics, and satellites. Without affordable supplies of these metals, industrialized nations could not develop the current versions of cleaner energy technology and other high-tech products that will be major sources of an economic growth during the century. Nations also will need these metals to maintain their military strength. The rare earth metals:
scandium, yttrium, lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium, which can be found in periodic table of an element.
Because of their superior magnetic strength and other unique properties, these elements and their compounds are very important for a number of widely used technologies. 12.1. What are the Earth's major geological processes and what are mineral resources? This question will guide us throughout the topic. The Earth is a dynamic planet. Geology is the scientific study of dynamic processes taking place on the Earth's surface and in its interior. Scientific evidence indicates that the Earth formed about 4.6 billion years ago. As the primitive Earth cooled over millions of years, its interior separated into three major concentric zones: the core, the mantle, and the crust. The core has two parts. These are the inner and outer core, mantle, which compose of upper mantle, lower mantle, and asthenosphere. Crust is composed of oceanic crust and continental crust, also the outermost part of mantle, which is lithosphere. First, we will tackle about the core. Core is the innermost zone. It is extremely hot and has a solid inner part surrounded by a thick layer of molten rock or hot liquid rock and semi-solid material. The core is made of two layers: the outer, which borders the mantle, and the inner core. The boundary separating this region is called the Boolean discontinuity. The outer core, about 2,200 kilometers or 1,367 miles thick, is mostly composed of liquid iron and nickel. Mantle, thick zone, solid rock that can be soft and pliable at very high temperatures. Solid rock is the outermost part of the mantle. Asthenosphere, a volume of hot, partly melted rock that flows. Tremendous heat within the core and mantle generate convection cells or currents that slowly move large volumes of rock and heat in loop within the mantle like gigantic conveyor belts. Some of the molten rock is the asthenosphere flows upward into the crust where it is referred to as magma. It is in the zone that we find the mineral resources on which we depend. Crust is the outermost and thinnest zone of solid material. It consists of continental crust underlies the continents, oceanic crust underlies the ocean basins and makes 71% of the Earth's crust. The combination of the crust and the rigid outmost part of the mantle is called lithosphere. What are minerals and rocks? The Earth's crust beneath our feet consists mostly of minerals and rocks. Mineral is a naturally occurring chemical element or inorganic compound that exists as a solid with a regularly repeating internal arrangement of its atoms or ions, or what we call a crystalline solid. Mineral resource is a concentration of one or more minerals in the Earth's crust that we can extract and process into raw materials and useful products at an affordable cost. Some of the single chemical elements includes gold, rare earth metals such as platinum. Rock is a solid combination of one or more minerals found in the Earth's crust. Some kinds of rock contain only one mineral such as limestone, calcium carbonate, and quartz silicon dioxide. Most rocks consist of two or more minerals. Example, granite is a mixture of mica, feldspar, and quartz crystals. Deposits of rare earths typically contain a mixture of the metals and their oxides that are difficult and costly to separate from one another and to purify to an acceptable level. There are three broad classes of rocks. These are sedimentary rock, igneous rock, and metamorphic rock. First, sedimentary rock. It is made of sediments, dead plant and animal remains, and tiny particles of weathered and eroded rocks. These sediments are transported by water, wind, or gravity to downstream, downwind, downhill, or underwater sites. They are deposited in layers that accumulated over time. Eventually, the increasing weight and pressure on the underlying layers convert the sedimentary layer to rock. Examples include sandstone, shale, dolomite, limestone, ignite, bituminous coal. Second, the igneous rock forms below or on the Earth's surface under intense heat and pressure when magma wells up from the Earth's mantle and then cools and hardens. Examples include granite and lava rock. Igneous rock forms the bulk of the Earth's crust but is usually covered by sedimentary rock. Third, the metamorphic rock forms when an existing rock is subjected to high temperatures, high pressures, chemically active fluids, or a combination of these agents. Examples include slate and marble. The Earth's rocks are recycled very slowly. Rock cycle is the interaction of physical and chemical process that change the Earth's rocks from one type to another. Rocks are recycled over millions of years by three processes: erosion, melting, and metamorphism, which produce sedimentary, igneous, and metamorphic rocks, respectively. In these processes, rocks are broken down, melted, fused together into new forms by heat and pressure, cooled, and sometimes recrystallized within the Earth's interior and crust. The rock cycle is the slowest of the Earth's cyclic processes and plays the major role in the formation of concentrated deposits of non-renewable mineral resources. we depend on a variety of non-renewable mineral resources. A mineral resource is a concentration of naturally occurring material from the Earth's crust. Found and extracted more than 100 minerals from the Earth's crust. Examples are metallic minerals such as aluminum, gold, and rare earths, and those made of compounds such as rare earth oxides and non-metallic minerals such as sand and limestone. According to the U.S. Geological Survey (USGS), the quantity of non-renewable minerals extracted globally increased threefold between 1995 and 2010. Non-renewable mineral resources are used for many purposes. Aluminum, used as structural material in beverage cans, motor vehicles, aircraft, and buildings. Steel, essential material used in buildings, machinery, and motor vehicles, is a mixture or alloy of iron and other elements including manganese, cobalt, and chromium. Copper, good conductor of electricity, which used to make electrical and communication, wiring, and plumbing pipes. Gold, component of electric equipment, tooth fillings, jewelry, coins, and some medical implants. Non-metallic mineral resource. Sand used to make glass, bricks, and concrete for the construction of roads and buildings. Gravel used for road beds and to make concrete. Limestone crushed to make concrete and cement. Phosphate salts used to make inorganic fertilizers and certain detergents. And many of today's important new technologies make use of various rare earth elements.
Hi everyone, I'll be reporting about how long might supplies of non-renewable mineral resources last. Non-renewable mineral exist in infinite amounts and can become economically depleted when it costs more than it's worth to find, extract, transport, and process the remaining deposits. Supplies of non-renewable mineral resources can be economically depleted. Most published estimates of the supply of a given non-renewable mineral resource refers to its reserves. Reserves means an identified deposit from which we can extract the mineral profitably at current prices. Reserves can be expanded when we find new, profitable deposits or when higher prices or improved mining technologies make it profitable to extract deposits that previously were too expensive to remove. We have never completely run out of non-renewable resource, but a mineral become economically depleted. What is economically depleted? It's the reduction in the value of a mineral deposit as the mineral reserves. At that point, there are 5 choices: recycle or use existing supplies, waste less, use less, find a substitute, or do without. Depletion time is the time it takes to use up a certain proportion, usually 80% of the reserved mineral at a given rate of use, as figure 12.5 shown. The shortest depletion time estimate assume no recycling or use and no increase in reserves, curve A. A longer depletion time estimate assume that recycling will stretch existing reserves and that better mining technology, higher prices, or new discoveries will increase reserves, curve B. The longest depletion time estimates, curve C, makes the same assumption as A and B, but also includes reuse and reduce consumption to further expand reserve. The Earth's crust contains fairly abundant deposits of non-renewable mineral resources such as iron and aluminum. The concentrated deposits of important mineral resources such as manganese, chromium, cobalt, platinum, and some of the rare earths are relatively scarce. 5 nations that supply most of the non-renewable mineral resources are United States, Canada, Russia, South Africa, and Australia. There are 4 strategic metal resources: manganese, cobalt, chromium, and platinum, which are essential for countries' economic and military strength. Global and U.S. rare earth supplies. Rare elements are not actually rare for the most part, but they are hard to find in concentration high enough to extract and process at an affordable price. In 2013, China produced about 80% of the world's rare earth metals and oxides. It's because China does not strictly regulate environmentally disrupted mining and processing on the rare earth. In United States and Japan are heavily dependent on rare earths and their oxide. China dominates the world in converting rare earth minerals to individual metals and oxides. Market prices affect supplies of non-renewable mineral resources. Geological processes determine the quantity and location of non-renewable mineral resource in the Earth's crust, but economics determines what part of known supply is extracted and used. According to the standard economic theory, in a competitive market system, when a resource becomes scarce, its price rises. Resource scarcity can also promote thievery. Example: because of increasing demand, copper prices have risen sharply in recent years. As a result, in several U.S. communities, people had been stealing copper to sell it, stripping abandoned houses of copper pipe and wiring and stealing outdoor central air conditioning units for their copper coils. They have also stolen electrical wirings from beneath city streets and copper piping from irrigation systems. According to economists, the price effect may no longer apply very well in most developed countries because countries often use subsidized tax breaks and import tariffs to control the supply, demand, and prices of the key mineral resources to such an extent that a truly competitive free market does not exist. Depletion allowances, permission to deduct their taxable incomes, the cost of developing and extracting mineral resources. Can we expand reserves by mining lower grade ores? Some analysts contend that we can increase supplies of some minerals by extracting them from lower grade ores. However, several factors can limit the mining of lower grade ores. It requires mining and processing larger volumes of ore, which takes much more energy and costs more. The dwindling supplies of fresh water needed for the mining and processing of some minerals, especially in arid and semi-arid areas. The growing environmental impacts of land disruption, along with waste material and pollution produced during mining and processing. Biomining is a way to improve mining technology and reduce its environmental impact is to use biological approach. Can we get more minerals from oceans? Most of the chemical and compounds found in seawater occur in such low concentrations that recovering these minerals resources takes energy and money than they are worth. Only magnesium, bromine, and sodium chloride are abundant enough. Another potential ocean source of some minerals is hydrothermal or deposits that form when superheated mineral-rich water shoots out of vents in volcanic region of the ocean floor. Show figure 12.6. A variety of exotic forms of life such as giant clam, 6-foot tube worms, and eyeless shrimp. Some analysts say that seafloor mining is less environmentally harmful than mining on land. Another possible source of metals from the ocean is the potato-sized manganese nodules that cover large areas of Pacific Ocean floor and small areas of Atlantic and Indian Ocean floors. So far, mining on the ocean floor has been hindered by the high costs involved, the potential threat to marine ecosystem, and arguments over rights to the minerals in deep ocean areas that belong to no one country. That's all. Thank you.
What are the environmental effects of using non-renewable mineral resources? Extracting minerals from the Earth's crust and converting them to useful products can disturb the land, erode soils, produce large amounts of solid waste, and pollute the air, water, and soil. Removal and use of mineral deposits have harmful environmental effects. Every metal product has a life cycle, and that includes mining the mineral, processing it, manufacturing the product, and disposal or recycling of the product. This is the process of extracting minerals and manufacturing it. So the first is the mining, then you can get the metal ore, and then you separate it from the waste materials such as soils or rocks. And then the next process is melting, which I will be discussed later on, and then melting metal, then conversion to product, and discarding the product and recycling it by going back to the smelting. The environmental impacts of mining a metal ore are determined partly by the ore's percentage of metal content or grade. So, the environmental impacts of the metal ore depends on the what percentage of metal content or grade it contains. Higher grade ores are more accessible. So, meaning ani dali ra siyang makuha. And the lower grade ores kay dako siya og environmental impacts kay danga kayo siyang ma-process. So there are different mining techniques that are used to remove mineral deposits. Surface mining. Remove shallow mineral deposits. The soil and rock called overburden are usually deposited in piles of waste material called spoils. Surface mining is where they get stones and metal ores. Nga naran siya sa shallow, and ang unang kuhaon sa mga miners kay ang mga trees, mauna silang mag-deforestation, and ang mga kahoy ang ilahang kuhaon kay para malimpyo ang ilang site nga ilahang minahon. Maong naay environmental effects ang surface mining kay tungod di siya sa deforestation nga mahitabo. Pareho aning naa sa picture, tungod sa pagkuha sa mga kahoy, nawala na ang mga kahoy og na bare na kayo ang mga mountains, so ma-prone na guni siya sa landslide and sa mga lain pang calamities. Different types of surface mining can be used depending on two factors: the resource being sought and local topography. Kung magmina ang mga miners, depende sa resources nga ilahang gibulong. For example, kung gold ba siya or kung copper ba. Then, local topography means depende kung unsay condition sa ilahang sites kung mountainous ba or dili. Open pit mining. Machines are used to dig very large holes and remove metal ores containing copper, gold, or other metals, or sand, gravel, or stone. So, sa open pit mining, magamit ng mga mumina o mga machines nga modig og holes. Strip mining. Any form of mining involving the extraction of mineral deposits that lie in large horizontal beds close to the Earth's surface. There are two types of strip mining. These are the area strip mining and contour strip mining. Area strip mining. Used where the terrain is fairly flat, a gigantic earth mover strips away the overburden, and the power shovel removes the mineral deposits or an energy resources such as coal. Sa area strip mining, naa siya machine nga move sa mga overburden or katong soil and rocks nga naa sa taas para makuha ang mineral nga naa sa ilalom pero sa mga flat nga lugar ni. Next is the contour strip mining. Is used mostly to mine coal and various mineral resources on hilly or mountainous terrain. Ang contour strip mining kay parehara ni siya sa area strip mining og process pero sa mga mountainous side ra pod ni. Mountain top removal, in which the top of the mountain is removed to expose seams of coal, which are then extracted. So, mountain top removal, ang kadalasan ani nga process kay kanang ilahang pabuthon ang taas sa mountain dayon ilahang dalon sa ilalom ang mga rocks o mga soil nga ilahang nakuha and i-process na nila para makuha nila ang coals. But this destroys forests and the streams in the mountains, so mo increase good ang risk of flooding. Ang process nila sa coal kay mogamit sila og mga toxic sludge. Then during the process ang ilahang mga waste and including the toxic sludge kay ma-store na siya sa mga dams. Toxic sludge contains mercury and arsenic, mga dangerous toxic substances ni siya. Mga dangerous ni siya sa mga tao, animals, and even the plants. Subsurface mining. Underground mineral resources are removed through tunnels and shafts, used to remove metal ores and coal that are too deep to be extracted by surface mining. Subsidence. The collapse of land above some underground mines. It can damage houses, crack sewer lines, break gas mains, and disrupt groundwater system. So, ang subsurface mining, para ni siya sa mga lalom nga parts nga magkuha og mga mineral deposits nga lalom na nga dili na madala sa surface mining. Ang mga mumina kay mudig sila og deep vertical shafts or tunnel to get the mineral nga ilahang kailangan. Mogamit sila og machine para mo transport sa taas. Sa subsurface mining kay less than 1/10 ang land nga ma-disturb than surface mining. So gamay ra gud ang waste material but it can cause hazards like muguha ang yuta and explosions and fires. And kabalo man ta nga gamay ra magugol oxygen sa ilalom sa yuta, so magka lung disease good ang mga miners, maglisod gud na sila ginhawa. And also the very big problem is the subsidence. Pwede mo collapse ang yuta sa underground tunnels. Surface and subsurface mining operations also produce large amount of solid waste, 3/4 of all U.S. solid waste, and cause major water and air pollution. Example for this is if muulan, then ang rainwater kay moadto sa mga mining sites nga ga-contain og H2SO4 or sulfuric acid and modiretso na siya sa nearby streams and groundwater, so makontaminate gud ang water nga mapadulngan ani. Case study: the real cost of gold. In 2012, the world's top 5 gold-producing countries were in order: China, Australia, the United States, South Africa, and Russia. Cyanide heap leaching is one way to extract gold. The miners will get crushed rock in the mountains and they will pile it up and isprayhan na nila og cyanide salts. And after that, ilahan ang i-drain ang solution sa settling ponds. And after ma-drain ang solution, makita na nila ang gold. And katong pond nga gidrain na nila sa solution kay mahimo to siyang toxic overnight. And that toxic can cause pollution. Another way is using toxic mercury to separate gold from its ore. Millions of poverty-stricken miners use toxic mercury illegally to separate gold from its ore, and they heat the mixture of gold and mercury to vaporize the mercury and leave the gold, causing dangerous air and water pollution. Many of these miners and villagers living near the mines eventually inhale toxic mercury vapor, drink mercury-laden water, or eat fish contaminated by mercury. Removing metals from ores has harmful environmental effects. Ores extracted by mining typically has two components: ore mineral containing the desired metal and waste metal. Tailings, rock waste that are left in piles or put into ponds where they settle out. Tailing ponds can leak and contaminate surface water and groundwater. If mag-remove og waste materials sa ore minerals ang mga miners, kay magamit na sila og chemicals. So, katong waste materials nga nasprayhan og chemicals, mao to siya'y gitawag og tailings. After the waste material is removed, heat or chemical solvents are used to extract the metals from mineral ores. Heating ores to release metals is called smelting. Sa smelting, dinhi na ang process sa pag-remove sa metals nga walay labot sa imong desired mineral. Without effective pollution control equipment, a smelter emits large quantities of air pollutants, including sulfur dioxide and suspended toxic particles, which damage vegetation and acidify soils in the surrounding area. Smelters also cause water pollution and produce liquid and solid hazardous waste that require safe disposal. Maong ang case study kay the real cost of gold is because sa kadaghan sa naguba nga mga parts sa environment kay mayra kaayo ang nakuha nga gold. So the environment is the real cost of gold. How can we use mineral resources more sustainably? We can try to find substitutes for scarce resources, reduce resource waste, and recycle and reuse minerals. We can find substitutes for some scarce mineral resources. Material revolution. The silicon and other materials are replacing some metals for common uses. So naatay mga substitute materials para sa mga scarce nga metals like silicons. The analyst also point out the possibilities of finding substitutes for scarce minerals through nanotechnology, as well as through other emerging technologies. What is nanotechnology? Nanotechnology, or tiny tech, uses science and engineering to manipulate and create materials out of atoms and molecules at the ultra-small scale of less than 100 nanometers. Graphene, a revolutionary material. Graphene is made from graphite, a form of carbon that occurs as a mineral in some rocks. Ultra-thin graphene consists of a single layer of carbon atoms packed into two-dimensional hexagon lattice, somewhat like chicken wire, that can be applied as a transparent film to surfaces. Graphene, one of the world's thinnest and strongest materials, and is light, flexible, and stretchable. Each single layer is 150,000 times thinner than a human hair and 200 times stronger than structural steel. And graphene is the true representation of the quote, small but terrible. Good conductor of electricity and conducts heat better than any known material. It's used to make stronger and lighter plastics, lightweight aircrafts and motor vehicles, flexible computers, tablets, and TV screens as thin as a magazine.
Environmental Science 12.5. What are the Earth's major geological hazards? Geological hazards are naturally occurring or man-made geologic conditions capable of causing damage or loss of property and or life. Geologic hazards mitigations is the application of geologic engineer principles to minimize or prevent the effects of naturally occurring geologic hazards. So these are the examples of geological hazard. Number 1, earthquakes. Number 2, volcanic eruptions. Number 3, landslide. Number 4, floods. Number 6, snow. Number 7, sand blasting or wind blow. So how can we use mineral resources or sustainable? How to live more sustainable lifestyle? So number 1, save energy. Number 2, eat less meat. Number 4, use reusable alternatives. Number 5, go paperless. Number 5, use renewable energy. Number 6, grow your own produce. Number 7, recycle and reuse, and many more. The earth beneath 4 feet is moving. So these are the earth beneath. Number 1, the inner core. And the number 2 is the outer core. And number 3, the mantle. So these are the 4. The crust. The earth crust is like the shell of hard-boiled egg. It is extremely thin, cold, and brittle compared to what lies below. The crust is made of relatively light elements, especially silica, aluminum, and oxygen. It also highly variable in its thickness. So these are the anatomy of the earth, which is crust, mantle, core, and inner core. So volcano release molten rocks from the earth's interior. Magma is extremely hot liquid and semi-liquid rock located under earth's surface. When magma flows onto earth's surface, it is called lava. Lava flow. Lava magma that has erupted onto the earth's surface is visually mesmerizing as the molten rock flows downhill. Lava exposed to the earth cools to a deep black color, while the molten rock beneath glows bright orange. Earthquakes are geological rock and roll events. So, geological activity can be defined as the movement of tectonic plates beneath Earth's surface. One of the main components for geological activity to be present is heat. In order for plates to move, there must be heat. So, these are the number 1 is normal. These are usually found at divergent plate boundaries. This is where plates move away from one another. These types of fault is where one block slips vertically downwards relative to the other thrust or reverse. So these are earthquakes on the ocean's floor can cause huge waves called tsunamis. So let's read. A tsunami is a series of extremely long waves caused by a large and sudden displacement of the oceans, usually the result of an earthquake below or near the ocean floor. This force creates waves that radiate outward in all directions away from their source, sometimes crossing entire ocean basins, unlike wind-driven waves which only travel through the topmost layer of the ocean. Tsunamis move through the entire water column from the ocean floor to the ocean surface.